task we're getting ready to talk about is inspecting gasoline fuel systems. We utilize our PTC checklist and our student trainee guide to help us go through everything. First things first, let's talk about hazards, cautions, and PPE. PPE is your typical inspection gear. Do also bring a 4-gas meter if we're going into a space with fuel tanks. That way we can make sure the atmosphere is good for us to be in there. Some of the cautions, we're talking about a higher flash point fuel and the tendency of the vapors to settle in the spaces. So any ignition sources that we may bring with us, we want to make sure we remove from our pockets, cell phones, any of those things. We have our 4-gas with us just to let us know if we enter a hazardous environment, we can get out. You may or may not require a marine chemist certificate to certify the space before you go in. Typically for small passenger vessels, T-boats and K-boats, we don't require the marine chemist certificate. We just rely on our 4-gas and the training we receive for entering confined spaces. So now on this vessel, we're getting ready to jump into the fuel tank space to conduct an inspection on the fuel tanks and then all the piping and associated systems down here. Since we do have fuel tanks stored below deck, they're required to have ventilation, a powered blower. So we'll make sure that the operator energizes that and opens up the hatch at least 15 minutes prior to us entering. But from the deck here, I can see we have 2 fuel shutoff valves for each fuel tank. They're properly labeled as to how they function and where they're located. Half of my pre-inspection is already done. So now we're going to jump in the space and take a look. Now that we're in the space with the fuel tank, one of the first things I like to do is actually look at the fuel tanks. Verify that they look like they're in good condition, there's no obvious signs of damage or leaks, that everything is clean, and there's no rust or corrosion. This is an aluminum vessel, so corrosion can be corrosion. If there's a lot of buildup, make sure you clean it away and you can take a look at the condition of the metal. I also like to look at all my fittings and connections to the tank. Because it's gasoline, anything connected to it that's not metal to metal contact needs to be bonded. So I'm going to verify that my bonds are on and that they're good, especially at the fill connections. I'm also going to look for all my fuel hose, make sure all the connections are good and tight, there's no leaks. All my fuel hose itself looks in good condition. Any of the bulbs, if they have any priming bulbs, are in good condition, not dry rotted rubber. Can actually give them a squeeze and make sure there's no leaks from them. I'm going to verify any of the safety systems in here are also set to go. On this vessel, we have a small fixed CO2 system inside the space. So we're going to take a look and make sure any of the firefighting servicing has been done and up to date. There's also in here a flammable vapor detection system. We rely on the servicing company to test that as well, but you may be required based off the vessel. They may have a way to test that while you're on board. Basically all it does is it'll detect if there's a flammable atmosphere in here and will alarm up at the control panel. That just lets them know that they've got a buildup of flammable vapors in the compartment. We're also going to verify that the blowers are operational and is actually running. Easy to do, you just go find where it's coming from and put your hand up and you should feel the blower working. Then on here, because there's a CO2 system, it also has a pressure switch which when activated will secure the blower. So we'll actually activate that, watch the blower shut down, and we'll be good to go. So now we're looking at the tank top. Gasoline tanks, all connections should be made at the top of the tank. There should be no connections anywhere else on the tank. So here I have my fuel shut off. This is where the fuel actually comes out and goes to my engines. And I have my fuel return line coming in right here. So verifying the hose connections look good, everything is good. In the back here is my natural ventilation. So this allows, when the space is sealed up with my ventilation running, my fresh air gets pulled in through here, sweeps across the top of the tank, and gets drawn out through the exhaust fan. Here we have our fill. Verified our bonding is connected to metal, metal to metal. Everything looks good here. As part of our holistic approach while we're doing inspections, just because I'm down here looking at a gasoline system, I'm also verifying my through penetrations and my bulkheads are all sealed and everything else looks good down here as well. Here we have our fixed CO2 extinguishing system for our fuel tank compartment. Here we have our pressure switch. When the CO2 system is activated, it applies pressure to this switch, which then will secure the ventilation in the compartment. That way we're not sucking out all the CO2 we just put in the space. Directly underneath it, right here, is our vapor detection sensor. This is what senses the flammable atmosphere inside the compartment and where we'll apply our test medium to set the alarm system off. So here's the bottom Here's the suction point of our exhaust blower. While the exhaust blower is running, if you can get your hand down near that space, you can feel the air being sucked past, meaning that the blower is working properly. Here we have our fuel coming from our tank to our fuel water separator, and then going out through our priming bulb, back out to the outboard engine. Verifying that this is all intact, no leaks, everything's clean and dry, and looks good. We also have our blower itself and the blower line going down to the other side, and it is operational. At this point is when we would activate our pressure switch for the CO2 system and have this fan shut down and verify that it works properly. So for vessels with internal combustion engines inside the hull structure, there's some additional requirements. This one's fitted with outboards, so it's not necessarily applicable here. But one of the things with your blower is there has to be a safety interlock involved. Basically, in order to start the engine, the blower has to be operating. This prevents any buildup of combustible atmosphere inside. That way, before you actually start the engine, it clears the space and sweeps the space full of any vapors, and then it'll start your engine. It has to remain running the whole time. If that blower shuts off at any time, it'll kill the engine. To summarize what we've been talking about, inspect the gasoline fuel system. Let's go over our PTC checklist to make sure we didn't miss anything. First thing we talked about was hazard, caution, and PPE to wear while conducting our inspection or examination. We talked about the safety aspects of prior to entering a space with gasoline fuel storage. We talked about safety systems. We talked about verifying the tank itself and verifying any fittings, piping, and hoses on board. Verified shutoff valves are properly marked and labeled and operate. Verified that they have any additional ventilation, in this case a blower exhaust assembly. Verified its functionality and system intact. And we talked about our vapor detection device and testing that. If at any point during this you have any questions or thought of something you might want to know a little bit more about, make sure you write it down and ask if you go when we're done.